Almost any situation where there is an unknown quantity can be represented by a linear equation, like figuring out income over time, calculating mileage rates, or predicting profit. Many people use linear equations every day, even if they do the calculations in their head without drawing a line graph. This module discusses the introductory concepts of linear translation. You are watching Mathematics of Engineering. A linear equation is an equation that can be written in the form ax plus b is equal to 0, where a and b are real numbers and x is a variable. This form is sometimes called the standard form of a linear equation. Note that most linear equations will not start off in this form. The different types of linear equations according to form can be taken as first, slope-intercept form, using the formula y is equal to mx plus b, where m is the slope taken as rise all over run and b is the y-intercept. Second is point-slope form stated as y less y sub 1 is equal to m times x less x sub 1. In this form, m is still taken as the slope or ratio of rise to run, and x sub 1 and y sub 1 is a point on the line. Third is, as introduced earlier, the standard form, which can be ax plus by is equal to c if there are two variables in the problem. In here, a, b, and c are constants. Algebraic translation is simply converting a verbal statement, say English sentence, into an algebraic expression or equation. Good advice in doing so: check the location of commas in the verbal statement to clearly identify if grouping of the terms is required in the algebraic expression. Different ways of verbalizing algebraic expressions depend on the operation. Take, for instance, addition. The words which would be observed are plus, more than, the sum of, the total of, increased by, added to, and others. For the operation of subtraction, words are commonly applied are minus, less than, the difference of, less, decrease by, or subtracted from. In case the operation applied is multiplication, the following words may be observed: times, the product of, twice or double, multiplied by, and also of. For division, the verbal expressions noted are the quotient of, divided by, and the ratio of. There would also be powers where we can take note of the exponents, such as the square of or squared, or the cube of or cubed. For algebraic equations, the equal sign will be denoted as equals, is the same as, yields, or amounts to. Let's translate some examples such as the following. 3 times a number divided by 10 equals 15. If we let n be the variable denoting the number, 3 times a number is taken as 3n, then divided by 10 equals to 15. Let's try this other example. Express the area of a rectangle whose length is twice its width decreased by 6. If we denote A for area, L for length, and W for width, the statement reflects that the length is twice its width decreased by 6. By substitution, we can take length as a function of width, thus plugging the expressions in the formula of area, which is length by width. We get the area is equal to twice the width less 6 multiplied by width.